Hi there. You made it through almost all the course. You learned the fundamentals of ML, along with some insights on what models are used. This last topic will focus on what is planned for ML in the nearby future. So let's go. We have a lot of fancy ways to teach computers to do tasks and, as I told you, some tasks are now done on smartphones. Researchers believe that at this rate, smartphones will have more and more importance on your lives, even more than now. This translates in more problems to be solved, tasks to be automated and new fields of research. And given the importance of ML and AI, expecting them to be needed even more on those platforms is not far-fetched. The issue is, smartphones are not as powerful as laptops and computers, so researchers need to adapt their models. Take into account object recognition, something that ML models can achieve already pretty well. It requires a lot of memory to load everything needed, and a big chunk of processing power is needed for predictions. In order to bring even more ML technology into smart devices, current models need to be optimized. It may not seem difficult, but there are lots of researchers actively studying methods to obtain this feat. Reducing the complexity of a model reduces its performance, and of course they want the best results. This results in compression, pruning and redesign research that is already giving neat results. Neural network compression, for example, allows to reduce the memory footprint of a model, still achieving the same results. Pruning removes unnecessary and redundant parameters, merging them with other. Redesign can be achieved by learning how models work, and improving them consequently. Another future development of ML, that has already been started, is real-time predictions. I never mentioned the time it takes ML models to make a prediction. Well, for most of them real-time is an unknown word tongue. But if researchers want to integrate ML even more in your lives, stuff should be done instantly. For example, there are models that can generate a description of an input image, in natural language. There is a red car parked in front of some trees. This is something that you may get as an output. How amazing would be to have a computer that can tell you in real time what happens. This is what some optimizations are aimed towards. As for now, most models rely on powerful servers to send the predictions in real time. Speeding up models started to be a more involved competition among researchers, and improvements are made every day. Another field that would benefit from speed improvements are games, autopilots, art creation and more. This problem is directly connected with the use of ML on smartphones. Lower power devices will slow down even more when the models are used. And you don't want it. The last future sector that I want to cover is ML and quantum computing. Don't know what quantum computing is? It's basically a computer that, instead of using just zeros or ones, can also use both at the same time for the same variable. Quantum computers have really neat properties that help certain particular tasks that require randomness. Future applications for ML will consist of what is called quantum machine learning. Fancy words, right? Why quantum machine learning? Because quantum computers could give a solid base to develop new approaches, and on the other hand, QML could be used to study how quantum systems work. From the three future aspects of ML, this is the newest and still emerging. Well, this is everything I wanted to tell you in this basic machine learning course. How was it? Did you enjoy it? If you liked something in particular, make sure to search about it. You will find many more details that for sure will amaze you. Smile. Of course, this course covered only the basics of machine learning. I didn't cover more advanced stuff, so you won't be bored if you are not interested in the technicalities. But I can tell you there are much more amazing concepts to discover, and I can give you some suggestions. Want to know how computers play video games? Reinforcement learning. A totally different approach on optimization based on evolution. Genetic algorithms. Ways to generate data without any knowledge on what it looks like. Generative adversarial networks. For now, that's all. You completed this course. I'm proud to have had a student like you to follow my lectures. Congratulations.